Though it's been 50 years since humans first stepped on the moon, we haven't forgotten about Earth's natural satellite. Several missions since Apollo have taught us so much about the moon and have paved the way for humankind's return. I'm Alana Bartolini from ESA Education, and here with me today to tell us a little bit more about these missions and future exploration of the moon is Dr. James Carpenter. James, thanks for joining me.
Hi.
So to start off, can you tell us a bit of a summary about moon exploration so far?
The moon, of course, is our closest celestial neighbour. It's something that humans have looked at and tried to understand forever, right? But then lunar exploration really began in the 1960s and 70s, where we had robotic and human missions going to the moon. From the lunar missions from the Soviet Union, which roved around on the surface and returned samples. But then really the pinnacle of this was Apollo, and the first and only time in history that humans have set foot on another celestial body. Now, that was not a scientific program. It wasn't done to create new scientific data. It was done for a whole set of other reasons. But at the same time, it was really transformative for science. So what we learned from the samples that came back from the moon was the origin of the Earth and the moon as a system that has a common origin. We learned that the moon has been an archive of solar system history, that the moon is the only place where we can go to learn about the history of our own planet, especially in the early periods that have been lost from our own terrestrial geology. So this was really transformative for our understanding of how planets form and evolve, and become the basis for planetary science and much of what we know about our own planet too. So that's something which started in Apollo and has gone on since then. So people are still using the samples that came back from Apollo 50 years ago to do new science. And that's something that's really taking off again in the present time in recent years. At the same time, after Apollo, we had this period where not a lot happened on the moon. It was very quiet. There weren't any missions there. The moon was quiet once again. And then the last few years, we've had this renaissance of lunar exploration. We've had new missions from the United States and from Europe with Smart 1, and then more recently from China and from India and Japan. And so these new missions have created a wealth of new data, which have really given us a global context for what came before. So we're now starting to understand everything that we've done before with these samples and these early missions to the surface, but really in a global way, finding out what this means in a broader sense and how we can interpret that better. It's also taught us that even though all these samples, all this science that was done in the past is the basis of so much of what we understand about the history of the early Earth and the planetary formation in general in the solar system, it's very incomplete. That the moon is a large place, has tremendous diversity. We've really only scratched the surface.
So taking all of that into account, what are the next steps? What's in store for the future of moon exploration?
So I think what is coming is very exciting. We have multiple countries, multiple agencies, and people outside of agencies in the private sector, people who are not from space agencies, but really have their own either businesses or their own fortunes, people who are very, very wealthy, who are trying to explore the moon now. India tried to land this year. They didn't succeed, but they have an orbiter now going around the moon and they plan future missions. A private sector mission from Israel tried to land on the moon earlier this year, was not successful, but that also was the first time a private sector company had tried to get to the moon. We have missions from China, so China landed on the moon this year, the first ever far-side mission, and they have big plans for the future, involving the establishment of a lunar research station, robotically initially, and then moving to humans over the next decade or two. And then in NASA now, in the US, we have the Artemis program, which is intended to bring humans to the lunar surface again for the first time since the Apollo era, and this time in a different way. So we'll be looking at doing science, exploring places that have never been explored before, but also exploring things like how we can use the local resources that we find on the moon to enable permanent, sustained and sustainable exploration to learn how we as a species can live and work away from our own planet. And we in Europe have a vision for exploring the moon, which is one about partnership and cooperation. So we want to deliver science, we want to prepare the future, we want to create the technologies and capabilities by integrating science and technology together that prepare us for exploring the solar system beyond the moon, but also establishing sustainable exploration of the moon for the benefit of humanity. And so we are working, particularly with the United States with NASA on the Artemis program, and we're very excited about the contributions that we're making to that and the developments that we're making in the coming years.
So one of the questions or things that we sometimes hear is, why are we going back to the moon? What are some of the reasons that we should continue exploring the moon?
Okay. So the moon is an archive of solar system history. On Earth, we have plate tectonics, we have water erosion, wind erosion, and this has removed the earliest periods of geological history of our planet from our own planet. Now the moon has remained geologically very stable for a very, very long time. And so as the sun has changed over time, as comets and asteroids have bombarded the inner solar system, as our solar system has moved through the galaxy, going through the spiral arms, through dust clouds, near supernovae, all of these events have had an impact on the inner solar system, and all of these events are recorded somehow in the surface of the moon or in the moon somewhere. And so by accessing the moon, we can find out about the history of our solar system, of our own planet, and about all of the things that have happened there over eons of time that have been lost from our own geological record. At the same time, the moon is a place where we can learn what it means to live and work off-world. So there are resources on the moon that we could conceivably use. So we now know that at the poles of the moon, we have very, very cold places that never ever see the sun. And these are some of the coldest places in the solar system, and we know that in these places now we have water, ice, and other we call volatile chemistry. This is the chemistry that creates the building blocks of life, but it also can be useful. So water is oxygen and hydrogen. Oxygen is useful for humans, and oxygen and hydrogen together are rocket fuel. So we could conceivably have a store of fuel at the surface of the moon that we could use to explore beyond. At the same time, the minerals around the moon are made of oxygen, metals, and silicon. And if we could find a way of separating those things, then we have oxygen, which again is useful for life support, but also for propellant, for fuel. And we have metals and things we might be able to use for manufacturing on the surface of the moon. We go to the moon to understand the moon and what it can teach us about planets. We go to the moon to understand what it can tell us about the history of our solar system and our galaxy and our star and the planets in the solar system. We go to the moon to understand the origins that we share between the Earth and the moon. And we go to the moon to use that as a platform to look outwards beyond. And we go to the moon to understand how we as a species can live and work off Earth in a sustainable way to prepare future exploration, but also to understand better how we can live and work sustainably here on Earth.
And so James, you're a moon scientist. How did you get started in lunar research? Did you think that you would be working to get humans to go back to the moon?
So if I told my 9-year-old self what I was doing now, my 9-year-old self would be very excited about it. I think that when I was a child, I was really excited about space and exploration. And then I reached my teenage years and it stopped being something that had any meaning because I didn't see this as something that was realistic. It was a childhood fantasy, if you like. And then it wasn't really until I was about 16 when I suddenly realized that this was a real thing. That even here in Europe, there were people that did this for a career. There were things that were happening here. And when I learned that, I had to do it. So I studied mathematics, physics, and chemistry at A level, which were the qualifications we had in the UK at that time. And then I went on to study physics with space science and technology for a degree. I did my PhD, and then after some years working on space projects in the UK, I came to the European Space Agency to support future exploration missions. And I think now is a really exciting time to be here and working on this because I think we are at the beginning of something that is going to be very exciting, very future looking, which is really going to be international and where Europe and we in the European Space Agency and where the people of Europe can be very, very involved. And I think if you are a student or a child today who is interested in space, there has never been a better time because when you are leaving school and when you are going into the workforce, these are the things that are going to be happening. We are going to be going to explore the solar system. We'll be doing that as a species in cooperation, and there are extraordinary opportunities waiting for you.
And with that wonderful sentiment, I want to thank you for being with us here today.
Thank you.
To all of you watching, thank you very much for watching this series. I hope that you have enjoyed learning about the moon with our ESA experts.